Awe. Cool. So this video, the last content video of chapter 1, yes. So it's basically simplification of fractions, and I didn't know exactly what to teach here, right? So I was like, I'm just gonna go straight and do a couple of examples, and then from those examples, hopefully you guys will understand and learn how to simplify fractions, right? Cool. And I want to say also here, you're going to take everything we have done so far into consideration, factorization being one of the most important one. And of course, the most important thing when you factorize is the number one thing you check, common factor. Do you have it or not, right? Then depending on whether you have it or not, you move in a particular direction, right? Cool. I bet let's start working with this number one. So number one, it looks really beautiful. I just want to say, okay, I'm realizing different things with number one. I have I have X, I have X, right? And I have B here, I have B here. So you already see that there are different pairs of groups in which you could decide to go with. Yeah, so let's go. I would start with the A. So that being said, you will have AX minus AB, right, plus X minus B, right? And on your denominator, it's just AX minus ABX, right? So with this, we can then group them. We can then group them, say that's our first group, this is our second group, and therefore if we factorize, you have A into X minus B plus you're gonna have, this is just gonna be 1x minus B, right? And then we factorize the denominator. You have A as a common factor, you have X as a common factor as well. You are left with A X minus B, cool stuff. You have common factors here, which is X minus B, so we start with them. You are left with A plus 1, then you have AX, right? And no, I left something, of course. AX into X minus B, right? So now you already see what's going to happen. The X minus B will cancel X minus B, and then that which you are left with is A plus 1 over AX. And yeah, now I also want to say something about this particular problem, especially for our numerators. Remember, I think you decide here. You decide if you want to what's the word, like how you want to pair them, right? I think there are certain problems where it's easier to do it in a particular way compared to the other grouping, but there are some other problem which it doesn't really matter that much, it's equally easy, right? So I'll show you by grouping them with B. So say I have minus B minus AB, right? And then I have X, so this is plus AX plus X, and then I group them. This is my first group, this is my second group. Therefore, common factor here, it's minus B, so I have minus B into 1 plus B, 1 plus A, 1 plus A. Then here my highest common factor is X, then I have A plus 1, so common factor here, this should have been 1, yeah. Highest common factor is A plus 1, and then I'm left with X minus B, right? Which you already see, it's exactly what we had here, right? Where this one was cancelled by by X minus B of our denominator. So it's a kind of the problem where it doesn't really matter. You could, pair them however. I think we had the AB pair, we had the B pair, which is also like the X pair. Cool. Let's move on. So now for this one, remember the very most important thing is your what? Your denominator. Not denominator, is your common factors. So perhaps just for the sake of convenience, now I'll just write this as 2a plus 2 times 5, which is 10, plus 2 times 2. Right, then you realize common factor 2. You have 2 into, you have a plus 5, right? Then you have 2 multiplied by 2, and then this 2 cancels out this 2. Therefore, you have a plus 5 all over 2. Right, very simple, straightforward. Cool. So here, number 3, and this 3 is looking a bit funny, but number 3, we have something interesting. On this part of the numerators, we have a summation of 2 cubes, which we have done the factorization of a summation of 2 cubes. So let's do it. So you know, of course, the answer will be p plus q as the first bracket of the binomial. The sign is positive, therefore we'll have p squared minus, and then you multiply the 2 together, pq, right? Then you always plus, then q squared. You are done with this guy. Over here we can then say p squared, right? Then of course we are multiplying by highest common factor, it is, which is 3. We take it out, we are left with p minus q. Then here it's a difference of 2 squares. We have also spoke about how to factorize the difference of 2 squares. You have exactly the same thing. What's gonna be different is gonna be the sign within the brackets. So you're done. Now you realize that this p plus q will divide this one, and then this one will divide this one, and therefore your final answer is going to be 3 into p squared minus pq plus q squared, right? And then here you have p squared, right? And then there's nothing more we can do. We are done solving this problem. Let's go to the next slide. Cool. Now we come across something very interesting now. With the fractions we're trying now to add or subtract. We are trying to add or subtract these brackets. Cool. We're trying to add or subtract these fractions. So now we know that when we are adding or subtracting, the most important thing is what is our fractions, is our denominators. So there's a very particular way of multiplication. In fact, let me illustrate it. You have 3 over 5 plus, let's see, 1 over 3. There is no way we can change 3 into 5 or 5 into 3. We cannot do that using natural numbers. We can't do that. So what we will do is the usual way of doing it. We will multiply by 5 over 5. We will multiply by 3 over 3, right? And then you have 9 over 15 plus 5 over 15, which is going to be common 14 over 15, right? So this is just a normal way of doing it, but I want to show you this method where you have 3 over 5 plus 1 over 3. So basically you start with the denominator. Your denominator is going to be a product of this times this, which is 15. The sign here is positive, right? So then you have 3 times 3, that's 9. 5 times 1, that's 5, that's 5, right? And then what you have here is exactly the same thing you had here. Let's use a different fraction. I'm thinking okay, I'm thinking 7 over 10 minus 11 over 13. I don't know if that makes sense. So perhaps let me make it 17. I don't know, 13 is fine. So with this, the normal way would be, of course, we can't make 10 into 13 or 13 into 10. So the normal way, we would say multiply by 10 over 10, multiply by 13 over 13, right? And then you still have your minus. Well, let me start with, you have 130, and then 7 times 3, that is 70, and then that is 21, 70, 21, 91. Then minus, here you have 110 over over 130. Okay, I'm seeing here I don't want it to be a negative value, so let me just put the number, let me just put them this way, right? So it's this one minus this one instead, so that means we will have something like this. Yeah, we're gonna have something like this, and I'm just gonna move it here. Cool. So now when we do our subtraction, it's going to have 9, and then you have 10, you have 19, right, over 130, right? So now when we do it, we have 13 minus 7 over 10. It's now I'm using this other method. You start with your denominator, right? These two multiplied together, you have 130, right? You have a subtraction sign, and then this 2 times this one, 110, right? And then this 2 times this one, let me see, it's 70 again, and 21, 7, 14, 21, so 21, 91, we're still correct. 100 minus 110 minus 91. So the reason I'm showing you guys this method and showing you that the method really works, it's that I want to use it. Yeah, it's a very simple shortcut. You see, like, we don't do a lot of yeah, it's not a bit messy, right? It's not a bit messy, but I will do it with this method that I'm showing you, and then you guys, perhaps you can try to do it with the old way of doing it, and just compare the answers, see if we have the right answers, not the right answers, see if we have matching answers. So cool. So with the method I've been telling you guys about, we start with the denominators. With our denominator, we are multiplying these two together, therefore you have x minus 12, you have x minus 6, right? Cool stuffs. And then you have your negative side, then this is gonna multiply this, so you have 12 into x minus 6, and then you have 6 into x minus 12. So basically this multiply that, you still have your negative. So continuing further, you have 12x, I think 6, okay, minus, you have 60, 72, then minus 6x, 6 plus 72. Okay, I just want to check. So we have a negative here, negative 72, and then negative plus. Cool. I bet. And then here your denominators, of course, which is just gonna be those two brackets. Now we're just adding or subtracting our numbers. So when we do that, we get 12 minus 6, right? So here we're gonna have positive 6x, and then 72 and minus 72 together, 0. So we then have x minus 12, x minus 6, right? Look, you can check with your other method, but like this one is just short and doesn't use so much space. Cool. Let's see what we have here. Oh my word. So I think there's a 1 that is missing here. There's a 1 that is missing here, and cool, we can start now. So Cool. Okay, so here, then I will say also, I think for this one, since there are three terms, it will be easier to use the old way or the original, like how we usually, sorry, how we usually solved or add or subtract fractions. Yeah? But also, the method that I've just shown you, it also works, but now you will have to do it step by step. So if you use the method that I've just shown you, you're going to have to start with these two first, and then you end with this one and this one, right? um yeah, so you start with this two first, this two, and then after you have added them, whatever you get, you are gonna add it to one, right? Let's see if it's really going to be messy or not, right? So we are focusing here. We start with what? The denominator. So starting with the denominator, we're gonna have a plus one this side. Denominator, it's this multiplied by this. I believe the answer is 36. Let's see. 9, 18, 20. Yeah, the answer is 36. So you have your negative sign here, and then what's going to happen, this 4, it's going to multiply 2x minus 4. So you have 4 into 2x minus 4, and then you have 9 multiply x minus 3, right? And then you're going to have cool. Then here, of course, you have 1, but you already see what's happening. The denominator is 36, so it could be like 36 over 36, right? And then yeah, you have 8x minus 16 minus 9x plus 9, 18, 27. Okay. 27 and 18, 27, yes. Then you have your plus 36. Everything is divided by 36, right? So I'm gonna start with the numbers because I think the numbers are positive. So here, if I say 16, okay, if I say 36 minus 16, the answer is 20. So then I add this one over there, and 20 plus 47, 20 plus 27, 47. So I have 47, and then 8 minus 9, that's gonna be minus x, and then everything is just divided by 36, right? I mean, it wasn't that messy. Yeah, fair. So okay, cool. I think I'm very happy with this method, and I want to say I'm just gonna continue with it. Yeah, I'm just happy to use it. uh I am just happy to use it. Okay, let's do the next problem, yeah, which is this gentleman over here. Cool. So with this problem, let's check. Can you factorize what you have on your numerators on the first term? Nah, just to see if there's any factorization needed. Here I didn't ask that question. I mean, I could have, because this is this is factorial. What is that word? Okay, well, let's make it easy. We are able to factorize this. It is factorizable. Alright, bad, forget about it. But yeah, this one we can factorize it. But also I just saw it wouldn't do me any good for me to factorize it, because my denominators is just literally numbers. So I'm not gonna expect any cancellation here because of that, right? You could just see it straight away. But here, my denominators, I have numbers as well as variables, and the same is true on my denominator. So there's a possibility that a particular bracket on my numerator can divide a particular bracket on my denominators. I don't know that. That's why I need to check. This guy, can I factorize him? I'm like 1 multiplied by 9 is 9. I have 9 and 1. I have 3 and 3. These are pair that gives me 9, or factors of 9. But there is no pair that gives me minus 3 whether I add or subtract. So that means I cannot factorize this one, right? Yeah, so and okay, so you see, for the problems that I'm saying you cannot factorize them, most of them you would realize there are some which they cannot be factorized at all, but then others they can be, right? The thing is though, when you factorize them, right, you are not going to get a number that is what am I trying to say? Like, you are not going to get a number that is rational. Yes, that's what I'm looking for. Cool. So we can't factorize the numerator here. We're just gonna continue. Therefore, you have x squared 3x plus 9. This we can definitely factorize because it's the same as x to the power of 3 plus 3 to the power of 3. So we have a summation of 2 cubes, right? And you know, we did the factorization. It's gonna be x plus 3, then it's gonna be x squared, then it's gonna be minus 3x, then it's gonna be plus 9, right? And you already see that these two will cancel each other out, right? You have x minus 2 here. We can't factorize that further. Can we factorize this one? The answer is yes. You have x plus, let me see, 3, then x plus 1, but it doesn't really also, it doesn't do us any good. How about this one? Just leave it as it is, right? Minus 2, right? So this divides this. You have 1 over x plus 3 plus x minus 2 x plus 3 x plus 1, right? Then minus 1 over x minus 2, right? Cool. So here we now gonna have to make our denominators to be the same. And upon doing that, I want to make you guys aware that if we try to attempt the method we've been doing, we're gonna make this problem so long, right? So here we can go the traditional way, right? So I'm just gonna create some space. I'm gonna create some space just in case we may need to do some multiplications. Cool stuff. So you see here we have x, we have x here plus 3, which is here. We don't have this one, so we'll multiply by x plus 1 over x plus 1. Of course, you should have here plus, and then you also see we don't have this one, so this side also will say multiply by x minus 2 over x minus 2. Now our denominators has everything. Here you're just gonna multiply by, we don't have this one, so x minus 2 over x minus 2, and then here we don't have x plus 3 over x plus 3. We don't have x plus 1 over x plus 1, right? So you see that once you are done, your denominator is gonna be x minus 2, x plus 1, x plus 3. This is what your denominators is going to be like. As for your numerators now, this is how it's going to be. You have x minus 2, x plus 1, you have plus x minus 2, x, wait, what? Okay, yeah, it makes sense. Minus 2, it makes sense. Then you have minus x plus 3, x plus 1. I think there's nothing you can do further to solve this problem. So we're just gonna leave it like this because we don't have any common factors, right? X minus 2 appear here as in here. It's not here. X plus 1 appear here and here. It's not here, right? X plus 3 appear where? Just here. Do you know what I mean? So yeah, it's all sorted. We are done solving this. It's by saying we are done solving this. I'm just saying we are done with chapter 1. The next video I will be solving some exam question, and we call it a day.